Hey guys, I'm sorry the Ziggy's getting focused. All right, so in the previous video, we talked about base 10 and how our number system is based on the number 10. Like, for example, your 1,000 has 10 of the 100 sheets in there. So 1,000 is 10 times greater than 100. 100 is 10 times greater than 10. And 10 is 10 times greater than a single unit. All right? So that works as it gets larger, but if you wanted to go in reverse, you could say a single unit is 1/10 the size of the tens. The tens is 1/10 the size of the hundreds, and the hundreds is 1/10 the size of the cube. So it's basically you're playing with the number 10. So right now what we're going to do is we're going to think about place value with decimals. Now, is doing place value with decimals going to be the same or different if we were to do it with a whole number? Think about it. The place value, is it going to be the same or different? Now, let's look at the model right down here. Okay? Now, let's look at this. This is a sheet. And if you remember, a sheet has 100 cubes in it. This sheet right here is completely filled in. So that means it is one whole number. So that means we have one sheet in the ones place. So that means it's a number 1. Now, let's look at the next one. We're still using the sheet, okay? Or the flat. The flat, I apologize. Now, remember, the flat has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 10 rods. Okay, and remember, a rod equals 10. So if you get 10 times 10, and that gives you that 100. Now, how many tenths, so that means how many rods, are colored in right here? 1. So that is 1/10. Now, you write 1/10 like this. You could either say 0.1 because the 1 is in the tenths place, or some people may write it like this, 1/10. But 1/10 is equal to 1/10. Now right here, you only see that there is one cube that is colored in. That is 1 out of 100. So that means that is 1/100 of the flat is completely shaded in. So 1/100. All right. So we have 1 plus 1/10 plus 100. Now, some of you are saying, or maybe thinking about this, how did they get 1 and 11/100? Because sometimes I have kids who want to do this when they add it up, and they'll come up and say, look, here's my answer. Well, and I'll say, let's try it again. When you add when you add decimals, you have to line up your decimal. So what they did, you have a number 1. A number 1 has a mysterious, invisible decimal to its right. It's always there even though we don't see it. So we're going to use this decimal to line everything else up. So you would go 0.1, and then you would fill in the blanks just like that and add. And that's how they got 1 and 11/100. Now let's look down at the very bottom, right here. Now, one more time, if you heard me say it, that is 1 and. Anytime you see the decimal, you say and. You do not say 1/1100. You say 1 and 11/100. Okay? 1 and 11 hundredths. Now let's look right here. In the decimal number, a digit in the one place has 10 times the value of the digit to its right. So basically what this means is every time in the place value, if you're going to move this way, the number is going to get higher by a tenth. So for example, you have 1 hundredths. If you multiply the 1 hundredths by 10, you get 1 tenth. All you do is you're going to move the decimal to the right. Okay? I know it's the opposite of the move. So 1 tenth times 10, we're going to move this decimal, and that gives me a whole number of 1. 1 times 10, we know this, is 10. 10 times 10 is 100. 100 times 10 is 1,000. So that is another example of how we are a base 10 system. Okay, now that was page 2. Let's look at page 3. All right, page 3 says, think. Okay, we got to have our thinking caps on, okay? If you break 1 hundredths into 10 equal parts, each part is 1,000ths of a whole. Okay, let's just think about that. If you break 1 hundredths into 10 equal parts, each part is 1,000ths of a whole. So what they're saying is you have 1 hundredths right here. All right? Now, if I were to break 1 hundredths into 10 equal parts, that is the same thing as me saying 1 hundredths divided by 10. Okay? That's what they're asking you to do. And when we divide by 10, okay, the decimal moves to the left. Okay? So 1 hundredths divided by 10 gives us 1,000ths. Okay? But if you look over here, you're going to say, well, Miss Moore, there's multiplication on both sides. Well, that's true. Because I can do this right here. I could say 0.01 times 1 tenth. Because when I divide by 10, that's the same thing as multiplying by a tenth. Okay? And if that confuses you, that's okay, because it took me a while to get used to it too. If you need to, just think of it this way. Each one of these is a divide by 10. Some charts show it this way, and I prefer to show it this way, but you need to know both ways. So let's look at the pattern on the chart. Okay? We're going to start with our whole number, which is 1. 1 is called a whole number because there is no decimal. It's not involved with the decimal, so it's called a whole number. Now, when you multiply times 10, 1 times 10 is 10. Okay? Now we're going to do the same thing with 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10 thousandths. All right, now, did you see a pattern? Yes. Okay, now look. They are increasing by a factor of 10. Okay? 10, 100, 1,000, 10,000. Or you could say it this way. They're adding a 0 each time they multiply by 10. Because look, I'm adding a 0. I took that 10, added another 0. Took that 100, added another 0. Took that 1,000 and added another 0. Okay? So you have a pattern. I'm sorry, I just did that. So you have a pattern of 10, and this is going to go the same way this way. Look at this. 1,000 divided by 10, take off a 0, and I get 1,000. 1,000 divided by 10, take off a 0, I get 100. 100 divided by 10, take off a 0, I get 10. Okay? 10 divided by 10 equals 1. I took away that last 0. Now, this is where some people get confused. Now, remember, there is that invisible decimal that's right there. Okay? And as you can see, and as you remember me saying over here, every time we divide by 10 or multiply by a tenth, the decimal is going to move to the left. So 1 times 1/10 or 1 divided by 10, I'm going to move that decimal one place over. And it turns into 1/10. Okay, same thing here. If I have 1/10 and I divide by 10, I move that decimal place one place over, and I get 100ths. If I have 100ths and I divide by 10, it's getting smaller. Move my decimal over, and I get 1,000ths. So every time you're dividing by 10 or multiplying by 1/10, the number is going to get smaller by one place value. Now, this right here, I'm going to be real honest, it's very confusing. So I'm actually just going to do that. So let's use the decimal. Okay, I find that the students, y'all do better when I talk about moving the decimal. When I have a decimal, okay, and that decimal moves to the right, all right, the number is getting bigger. Okay, for example, if I have 1 and 2/10. If I have 1 and 2/10 and I want to multiply that by 10, this decimal is going to move to the right one time. So it's getting bigger. So my 1 and 2/10 now is 12. Okay? So 12 is 10 times larger than 1/10. But we could do this also. If the decimal moves to the left, it's getting smaller. So that would be 12 divided by 10 equals, now since we're dividing, the decimal moves to the left. I get 1.2, or 1 and 2/10. So 1 and 2/10 is 10 times smaller than 12, or you could say it is 1/10 the value of 12. Now, and we'll get to this in the next lesson, but when you write, like with your decimals or whatever, especially with a whole number, your whole number goes here, and we said that was 2/10, so you would say 2/10. Okay, since it's 2/10, it would be 2/10. If it was 200ths, it would be 2/100, and even 2/1,000. So you just put it over there. Okay, let's look at number 1 right here. Which number does the digit 5 have the greater value? I have 500ths or 5,000ths. Okay, that's the first question. The second question, how many times as great is the value? Okay, so what I always tell the kids is let's line these numbers up. I have 500ths compared to 5,000ths. Now, if you remember, I said this the other day when I was doing a video. I said the further away the number is from the decimal, the smaller the value. So if I have 500ths and then I have 5,000ths, which 5 is closer to the decimal? the 500ths. All right, so the first part of the question is, in which number does the 5 have the greatest value? So we can say the 5 in 500ths has the bigger value of the two numbers. All right, now this is where we have to look. How many times greater is 500ths than 5,000ths? Let's look at it. If you remembered, let's just look. Okay. How many places would I have to move this 5 over to equal the 500ths? Okay, I would have to move it over one time. And remember, each time I move is equal to 10. So we could say this one of two ways. We could say 500ths is 10 times larger than, I'm sorry, we're comparing, it's A, 5,000ths, or we could say 5,000ths is 1/10 the value of 500ths. Now, that is lesson 1.1, the first one. Okay? That's the very first lesson we're going to be working with. Now, something that we're going to need to do after we do this is we're going to be working on pages 3 and 4 out of your workbook. Pages 3 and 4 out of your workbook are in the book that's not shiny. It looks kind of dull. So go ahead and take a break, and then we'll get to that video here in a second.